Hey class, these are the notes for the decomposition. Now I'm going to ask you to submit the notes because there's quite a few notes to go over. So please go ahead and make sure that you catch all the stuff that I'm writing down here and include that in your notes that you submit for this assignment. Okay, so let's get into this. Don't forget about the 4 different types of reactions. We've done this before. There we go, 4 types of reactions. Our first type is synthesis. That's the one we just went over. Pretty easy. We take A and B and we put them together to form a compound on the right-hand side. That's pretty simple. Decomposition is when we have a compound here and we break it up into A and B. Now A and B can be elements or they can be compounds, as you'll see in the examples. We have a single displacement. Single displacement is when I take either an element or a non-metal or a metal, either a metal or a non-metal, and add to the compound, and it switches places with either the positive part or the negative part of the compound. Either it's a cationic where it replaces the cation, or it's anionic where it replaces the anion. So that's single displacement. Double displacement is the one that's so simple and easy because it only happens in one way or one pattern, and that is when the pluses and minuses of the 2 compounds that we have in the reactants switch places. The minuses switch places like this, and we get AD on the other side and CB. Okay, just thought it was nice for you to hear all of that again because we're going to continue to go over this with notes. Here's a decomposition reaction. Here's my AB. It's definitely a compound. You will see sometimes, many times, it will be written as like a compound plus heat, and that's a dead giveaway that we have a decomposition reaction when you see the plus heat. Okay, so AB yields A plus B, such as if we take a look at this, you know we have mercury and oxygen, and if we separate them like this, on the other side I get mercury and oxygen. And because of Brinkelhoff and oxygen's by itself, it needs the 2. Okay, notice that there's no 2 on the left-hand side because Brinkelhoff does not happen with any element when it's in a compound. Okay, so there's no 2 for oxygen on the left-hand side because it's not part of Brinkelhoff unless it's by itself, and this plus sign says it's by itself. So let's keep going here. I have another compound called potassium chlorate. Potassium chlorate breaks up in a very specific way. It breaks up, instead of breaking up into potassium and then ClO3, it breaks up kind of like this. Now how would you know that? We're going to go over the notes for this. Okay, so this is a very specific type of decomposition reaction, and so is this, and of course so is this. So there's 3 types I'm going to show you. Now if I'm going, oh, you know what I didn't do in the first example? I didn't balance the equation. Notice I have 2 on the right-hand side, and I need a 2 over here to get 2 oxygens on both sides. That means I need a 2 in front to get 2 mercuries on both sides. Okay, now let's get back to my example number 2. You'll see KClO3. This is a chlorate. Chlorates decompose in a very specific way. You get the metal chloride plus oxygen. How do you know that? You're going to see the notes. Okay, it's going to happen. I'm going to show you how it works. If I put a 3 in front of the O2, that gives me 6 oxygens, and if I put a 2 in front of the KClO3, that gives me 6 oxygens. But that also means I have 2 Ks and 2 Cls. So I put a 2 in front of the KCl on the right-hand side. Okay, well, I'll go over this slower when we get to the actual notes. These are just examples for right now. So here I have calcium carbonate for my 3rd example. Carbonates break up into calcium with oxygen, which means I need a +2 and a -2 plus, and then CO2 is my other product. How do you know CO2 is the other product? I will show you in the notes that's coming up. Okay, I'll show you how to do all of this. So here I have CaO plus CO2. I have 1 Ca here, 1 Ca, 1 C, 1 C, and 3 oxygen. And here I have 1 plus 2 equals 3 oxygen. So this is already balanced for this example. Okay, get ready. Here come the notes. The first one we're talking about is when we have a compound that has a hydroxide. Okay, an example of a decomposition with a hydroxide might be CaOH2, and then that decomposes into something else. Now, here's the rule for all hydroxides except those of alkali metals. What are alkali metals? Alkali metals are the group 1 metals. That means they are lithium, sodium, potassium, rubidium, cesium. Those are the group 1 metals. Of course, francium is in there, but we never see francium. I think there's something like less than 1 gram of francium on the Earth. So it's very, very, very rare. So group 1 metals, lithium, sodium, potassium, rubidium, and cesium. That's, of course, referring to group 1 from the periodic table. So magnesium is not a group 1 metal. Okay, so we can continue to say that it loses water. Now here's what that means. It means H2O. You can write H2O as a product. When something loses it, that means that it's contained over here and then lost here, which means it shows up as a product. And then the metal oxide. The metal is magnesium. That is magnesium, and we must do our crisscross now, +2. And oxide means just what it says, oxygen, and it always has a -2. Okay, so we're lucky with this one in that the +2 and -2, we don't have to crisscross that because it equals 0. And I go back and I check to see. I'm going to erase some of this stuff because it gets kind of confusing. I go back to see. I have 1 mg on the right-hand side and 1 mg on the left-hand side. I have 2 times 1 is 2 hydrogens here. I have 2 times 1 is 2 oxygens here. Over on this side, I have 1 plus another 1 equals 2 oxygens, not 20, that's 2 oxygens, and I have 2 hydrogens here. So we actually have everything balanced. So my last step will always be balancing once I write down the products. What are the products for a hydroxide? Water and metal oxide. Make sure that when you get to here that you crisscross the metal oxide. Okay, let's take a look at the next one. So here I have sodium hydroxide plus heat. Notice the plus heat means it's definitely a decomposition. So what is sodium? Sodium is a group 1 metal. So what does that mean? It means we have a no reaction. That means that sodium hydroxide would melt before it would decompose. So if you had solid sodium hydroxide, it would not decompose with heat. It would actually just go from a solid to a liquid, not changing its structure at all. It would still be sodium hydroxide. The NR means no reaction. And if you see RXN, that also means reaction. Same thing. Okay, good. Let's keep moving. Sulfates, such as example of copper sulfate, okay? And if it would decompose, what would it decompose into? This is an example of a sulfate. Okay, right there's the example. With the exception of alkali and alkaline, earth, that means group 1 and group 2. Earth sulfates. Decomposition yields the metal oxide. Here we go, metal oxide and sulfur trioxide. That's prefix. Excellent. So here I have aluminum. Aluminum sulfate, Al2SO4, 3, plus heat yields the metal oxide. The metal is always the first one. That's aluminum. The 2 drops out. We get rid of the 2 when we go to the other side, and we write symbols and charges like that. Oxygen is a -2. That's the metal oxide. Now I just have to go through and crisscross to get Al2O3, like that. And then plus sulfur trioxide. Sulfur trioxide is 1 sulfur and 3 oxygen, like that. Excellent. Calcium sulfate. Oh, I didn't balance. Okay, let's go back and see if we can balance this. Um, 2 aluminums on the left-hand side, 2 aluminums on the right-hand side. So we got the same number on both sides for aluminum. I have 3 sulfurs because 3 times 1 is 3 sulfurs, and 3 times 4 is 12 oxygen. So 3 sulfurs and 12 oxygen. What do we have on the right-hand side? Well, here I have 3 plus another 3 is 6 oxygen, but let's do oxygen last. So how many sulfurs do I have on the right-hand side? I have 1, when on the left-hand side I have 3. So I go 3 in front, that gives me 3 sulfurs. It gives me 3 times 3 is 9 oxygens. Over here I have 3 oxygens plus 9 equals 12 oxygens. Excellent. I think I'm balanced on both sides. 2 aluminums, 3 sulfurs, and 4 times 3 is 12 oxygens on the left-hand side and 12 oxygens. 3 plus 9 is 12 oxygens on the right-hand side. So take a look at our next problem. Our next example is CaSO4. So CaSO4 is, Ca is a group 2 metal. Calcium is right below magnesium in the second group, so it goes beryllium, magnesium, calcium, barium, strontium, barium, and then radium. So here we have calcium, which means this is the easiest kind of all, which means a no reaction. I don't have to write anything on the right-hand side for that. Does not change. All right, I'm going to pause there and pick up with C and D in a new screencast.